Let's write this program now. Hey guys, this is Luca, Crusader Machining. Thank you for tuning in for another YouTube video. In the past few videos, we've been covering G codes, specifically cam cycles, G83, G71, G92. We're going to continue on that route today, but we're going to go just a little bit different. Let me set the scene. The other day I was walking through the hardware store. I was looking for a very unique screwdriver, not sure what it was, but I was looking for one. And all of a sudden, a disgruntled elderly gentleman walks up to me and says, "Hey Luke, everyone's talking about those G codes, those CAN cycles. That's good and all. Well, let me talk to you about G92 for a minute." And he steps up to me, hands me a fitting he found in the plumbing section. He says, 3/4 16. Program it. And that's what I think we're going to cover in this video. We're going to get down to the nitty gritty, and I'm going to show you how I would program a 3/4 16 from a print, and we're going to stick it to that disgruntled elderly gentleman. Class is in session. Let's do it. So we're going to hop right in, and for the time being, we're going to try to mentally divorce ourselves from this aggressive situation that we were in. We're going to focus on the challenge. What we're going to be going over in this video, as the introduction implies, is programming a 3/4 16. Three things that we're going to do in this video. So the three things we're going to go over is, what info do we need? Where to find this info? Detailed explanation. And last but not least, we're going to show that old man a lesson. The program itself. Now let's get right into it. What info do we need? Let's do it. So for the first section, we're going to be going over what info do you need. The first thing you need to know is a CNC programmer programming a 3/4 16 OD thread. You got to see the print. So I'm going to blurb in for just a minute. We're going to take a look at the print so we can all be on the same page. You'll see the thread length and any other pertinent information. So now that we've all seen the print and we're on the same page as far as what it is that we're doing, let's go over what info do we need. First thing that we need is your starting point in both X and Z. The starting point's important because if you end up trying to start too close, you're going to smash into the part. You start too far away, you're going to waste time. So you want to be, before you start engaging in any threading cycle, G92 or G76 for that matter, you want to make sure that you have a safe and practical approach position. You need to be away from the face of the part in both X and Z axes. The next thing we need is an ending point. That ending point's important for two main reasons. Your ending point has to be sufficient to make a complete thread. Also, you don't want to go too far in case you're going against the shoulder and you hit the shoulder. So you need to have an appropriate ending point. The next thing that you're going to have to figure out, you have to figure out the number of passes that you're going to take on a particular thread. That's determined upon the pitch. The pitch is threads per inch, or in metric, the metric pitch that's specified on the thread. Another very important thing that we have to find out is our feed rate. What is the feed rate going to be? Your feed rate is equivalent to the pitch. As the thread is moving, it's like a helix, as it's moving, your feed rate is going to determine the length of each individual thread. So your feed rate is how fast does it feed over the part when it's getting ready to thread. The last thing I want to cover, and we're not going to touch on this too much in detail in this video, your RPM and tooling. For the sake of the video and shutting up that old man, we're going to give it an arbitrary RPM, say S1000. And the reason I don't want to go too deep into it is RPM of a thread or any machining application is much more complicated than choosing an RPM. It's your surface footage. You want to make sure to have an appropriate surface footage for the type of material and the type of tooling and the type of machine that you're using. That can be a little bit more complicated, and we're probably going to cover that more in a later video. So for right now, just based on the ease of the video and getting over this challenge from Home Depot, we're going to give it an arbitrary RPM that I feel of 2 decades experience will work for a 3/4 16. G97 S1000 M3. Tooling, you want to make sure that you have a single point lay down threading insert, okay? Well, I like the lay down style. You can use a top notch style like from Kennametal or a Pentecut style from Iskar. I like a 3-edge lay down insert that tops the thread. I don't want to get too far into that either, because when you start opening up a can of worms in tooling, a lot of people will argue with one another based upon Sandvik versus Seco, Iskar versus Kennametal. They all work really well, especially for a simple application like single point threading. So now that we know this information that we need, we know what we need, now let's dive into it. I'm going to put a couple pieces of literature up right before we start the next section, and let's figure out that info specifically together. You should definitely either screenshot or pause this and take a look at this form. You can see the section circled blue is our 16 threads per inch, and each one of those is a breakdown of our depth of cut per pass. This is a page out of the machinery handbook that's a breakdown of their screw thread section, and you can see on the left the type of thread, and then every different column is a different characteristic of that thread, your pitch, your major, your minor, stuff like that. This is the same thing as the previous sheet, but I just clipped out a section so you could better see the numbers for the 3/4 16 that we're programming. So in this next section, we're going to go over specifically the info that you need to make the thread. Previously we talked about what info do you need. We have our list of what we need. Now let's get to the nitty-gritty. First thing we went over before was our starting point. If you go back and look at the print, our starting point would be Z0 on our face if we were to go right there, but remember we want to give it a little bit of clearance. So we're going to have our starting point in the Z-axis of 0.1 and in the X-axis of 950. The turn diameter on our print was 740 to 744 customer requirements. We're going to leave about 100 aside in X, in our position on X. We're going to be away from the face, Z positive 0.1. That should give us plenty of room to be safe and not waste time with inefficiency. Now we need to know our ending point. If you go back and look at the print, you'll see our ending point is 690 to the shoulder, 690 thousandths. So if you were to program your G92 to Z negative 690, you would hit that shoulder or come pretty close depending on where you touch off your tool. The thread relief is 105 thousandths. So if you take your 690 length, subtract your thread relief, you get 585. So if at 585 is the last point that we would want to go to make a complete thread, we're going to give it a little bit more, and we're going to go to Z negative 600 thousandths. That'll be enough to bring us into that thread relief, but keep in mind, depending on who touches off the tool, how they do, and what tooling you use, that Z negative 0.6 will most likely need to be adjusted either in an offset or in the program itself. So now we're going to get into a little bit more math here. We're going to go over the depth of cut per pass and how far you want to cut that thread down. So we're going to take a little break. I'm going to put up on the screen the sheets that I use from Seco to determine your depths per cut. And I'm also going to post it up there, the machinery handbook, your thread route on that particular thread. So now that you guys are able to take a look at some of the sheets that I use for my threading programs, the Seco recommended depth of cut sheet and a machinery handbook, let's dive a little deeper into that. So this could be a little bit confusing. If you look at the Seco sheet that was provided, and I recommend if you see anything on my videos, screenshot it, keep it in your photos. Sometimes it can be a help. I do that all the time. So on that sheet it gives you, there's a section I marked blue, and it gives you your recommended depth of cut per pass, plus the number of passes. So we're a 16 pitch thread. It's in metric. I converted that for myself into standard, but the key point is that metric number is your depth per side. So when you're dealing with a lathe, you deal with a lot of machining and programming in that regard per side. So the first number is 0.22. I converted that into standard, so it's 8.5 per side. You're going to double that and program it on the diameter. So our first cut would be 17 thousandths, then 16, 12, 11, 10, 8, and 6. Now that you know it's 7 passes that we're going to take and what those values are, what do you do with them? You find your major diameter. In the sheet that was posted from the machinery handbook, it has a recommended major, or on our print, in this example, they want a 740 to 744 diameter. We're going to call it 744. So you would turn it to 744. Each value in that Seco sheet, you're going to subtract that from 744 until you get to the end of the recommended passes. So our first depth of cut would be 727, which is 744 minus 17 thousandths. 727, then 711, then 700, 690, 682, 676. Each cut is going to keep cutting it down from the major until it gets down to that recommended point, which should be really close to the root of the thread in the machinery handbook. If you look back at that sheet, the root is 674. Our program is coming out to be 676, it's pretty close. Another thing about G92 and your recommended threading depth of cut, each subsequent cut, it gets less and less depth of cut. The reason that is your insert is 60 degrees on center, so it's a small point that gets bigger as you get deeper in the cut. So as your first depth of cut, you're cutting with a real small part of that thread. The deeper you get in the cut, you're cutting on the flanks of the insert. So to maintain good tool life, chip control, and surface finish, it's recommended that the further down you get into the thread, the lighter your depths of cut are. So we know what those values are. The last thing to go in, the last bit of information that we're going to go over is your feed rate, which is arguably the most important. The reason I say it's the most important is you cannot have a functional thread without the correct pitch. A thread is a helix, okay? And each feed rate, or each thread, is the size, the length of the pitch. So on this thread, you have 3/4 16. 16 is your pitch, or your TPI, threads per inch. So you have 16 threads per inch. Our feed rate has to correspond with that, or it won't be a functional thread. How do we determine that feed rate? We say 1 divided by your pitch, or threads per inch, 0.0625. Our feed rate is 0.0625, which would look in our program F.0625. That's our feed rate to give us that exact thread length of 16 threads per inch, or 0.0625 per thread. So now that we have all the information that we need to make this program, let's do what we do best and write it all together. In this next section, I'm going to show you the way I write that program and what my program will look like after all the information that we've acquired. Let's write this program now. Done. Wouldn't be a bad idea to either screenshot or pause it right here. So we got our program done. I think we showed an old man a lesson, and I highly doubt that he'll go harassing people in the grocery store anymore when they're going shopping for bread. But I get where he's coming from. Everyone's saying lately, hey Luke, you're going over all this programming, what's the deal, man? You think you're so good? And yeah, I think I'm okay. But that brings me to a wonderful point. The way we programmed in our video today is the way I program. You or someone else you might know, they might program it different, and that's fine. There's a lot of ways to program. There's not one right way, but there's plenty of wrong ways to go about doing it. So I'm pretty satisfied with the work that we did today in this video. We went over what info do you need to program a G92, where to get that information and how to get it. And lastly, how to take all the info we grabbed, put it into a program. Mission accomplished. We did what we came to do. Is it perfect? Probably not. Is there people that could dissect and say, well, I would do this and I would do this different? Probably. Like I say, there's not one right way, but there's a lot of wrong ways to go about doing something. So, video is concluded. And in conclusion, I want to say thank you for watching. Please subscribe. Take a look at the other videos. If you have positive or negative things to say below, comment. Thank you very much. And until next time, this was Luke with Crusader Machining. Thank you again.